In this video, we'll look at average rate of change. That is, how quickly or slowly a function changes between 2 points. We'll go through average rate of change, we'll talk about average rate of change of linear functions, and we'll do a quick example at the end. Now to motivate this, I'm going to draw a quick curve for you. Let me get the axes up, like this. Now suppose that I had some curve that looks like this. So that blue curve is our function g. And when we talk about average rate of change, we talk about how quickly or how slowly something is changing from one x value to another x value. So in this particular case, maybe we're looking at the average rate of change between this point, this x value, and this x value. To find the average rate of change between those 2 points, we need to know essentially the slope of the line that connects these 2 points on the graph of g. So this point here, that would be g of b, and this point down here, we'll call that x value a. This is going to be g of a. So we're trying to find the slope of that line connecting these 2 points. Now, fortunately for us, finding the slope is relatively easy. We're pretty familiar with this. We need the run and we need the rise, because that'll give us the slope of that line there. So the rise in this case will be g of b minus g of a, and the run equals b minus a. That length, right? So to find this length, we need to grab a and subtract it from b to get that total length. So then the average rate of change, you'll see AROC very often. That just means average rate of change. So the average rate of change is g of b minus g of a over b minus a. Now again, this is useful for us in a lot of higher levels of mathematics, but at this point we're just trying to get a sense of how much a thing has changed over time. We miss this information in the middle. Like all that stuff that's going on there is not included in the information about the average rate of change, but we can get a pretty good sense of how something has changed over time. So formally, the average rate of change of a function y equals f of x between x equals a and x equals b is the change in y over the change in x, which we just found was f of b minus f of a over b minus a. The average rate of change is the slope of the line connecting the points a, f of a, and b, f of b. So taking a look down at this graphic down at the bottom, hopefully I've made this pretty clear. The run is the distance along the x-axis, the distance between the two x's, and the rise is the difference between the two y's. So the average rate of change is the rise over the run, which is f of b minus f of a over b minus a. Let's find the average rate of change of this linear function. So this is f of x equals 2x plus 5, and we're going to find the average rate of change in 2 specific cases. So the average rate of change will be, first, f of 2 minus f of 0 over 2 minus 0. So remember, we start with the bigger number, the more positive number. Sometimes you might have a negative number. So we'll do f of 2 minus f of 0 over 2 minus 0. So this will be 2 times 2 plus 5 minus 2 times 0 plus 5 over 2 minus 0. And that gives us, that's 4 plus 5, which is 9 minus 5. So that's 4 over 2, which equals 2. So the average rate of change between x equals 0 and x equals 2 is just 2. What about between x equals 2 and x equals 7? So again, we do f of 7 minus f of 2 over 7 minus 2. And this will give us 2 times 7 plus 5 minus 2 times 2 plus 5 over 5. So 2 times 7 is 14 plus 5 is 19 minus 9. So that's 10 over 5. And again, we get 2. Maybe this doesn't come as a surprise to you. Thinking about it, if I were to draw on a set of axes some linear function, so maybe it looks like this. This is the linear function. It would make sense that for any 2 points that we took, let's look at 2 cases. Suppose we looked at this one and this one. The average rate of change is the slope of that line between those 2 points, which happens to coincide with the slope of the function itself. And similarly, if I grabbed this, and let's do this point and this point, we need the rise and the run. The slope of the line that connects those 2 yellow points is also coinciding with the slope of the function itself and the slope of the line connecting the 2 blue points. That is to say that the average rate of change of linear functions is constant. Let me just write that out so you can see. The average rate of change of linear functions is constant. Kind of a nice thing to have in your back pocket. And last but not least, let's suppose that we have h of x equals 1 minus 3x squared. Let's find the average rate of change between x equals -1 and x equals 4. So again, we put the bigger value first, h of 4 minus h of -1 over 4 minus -1. So that'll give us 1 minus 3 times 4 squared minus 1 minus 3 times -1 squared over 4 minus -1, which will be 5. So 1 minus 48, that's -47, minus 1 minus 3 times 1, so that'd be -2, 1 minus -2 over 5. So that should give us -45 over 5, which equals -9. So the average rate of change between x equals -1 and x equals 4 is -9.